So we are going to do systems. 8-1 is on 2 equation systems, 2 variable. 8-2 is on 3 variable. Okay, so we're doing 2 lessons. Now let me ask you this. Don't even write this down. Listen to me. Do you know how to check to see if something works?
Yes.
You're plugging in the x and y in both equations. If it works for both of them, then it's a solution. Do we need to go over that?
No.
Okay. Using substitution. So you use substitution. The only time you should use substitution is if one of the equations has a variable either by itself or easily gotten by itself. So do you see the second equation? I can rewrite it real quick as y equals 2x plus 9. See that? And then we're going to say, well, if y equals 2x plus 9, in the top equation, I can replace the y variable with 2x plus 9. So now I have an equation just with one variable, and you would just solve it. Right? We can do this. 8-1 is nothing different than you've learned in algebra 1 or whatever. So you solve for x. X is -6. And then you would take this and pop it up there to get your y. All right. So then we go to then we're going to go to elimination. So you need to pick what variable you want to get rid of, x or y. It's up to you. Sometimes it's easier to get rid of one than the other. But you want x? Okay, so we're going to get rid of x. 2 and 3, what number is the first one that you both go into? 6. Now remember, we want these to be opposite. So the top line, to get that to be a 6, I'm going to multiply by 3. The bottom line, I want to be a -6, so I'm going to multiply it by -2. Everyone with that? Remember that? So 6x plus 9y equals 63. -6x plus 8y equals -46. When you add the lines together, you're going to eliminate the variable. And you get y equals 1. Okay. Now it takes a second to figure out the x because you have to plug in the y, and it's not as quick as the substitution method. You should always double check your answer. So we have the point 9, 1. Check it with both equations. Make sure it works. That's how you're going to tell if you made a mistake. And it's easy to make a little quick sign mistake or whatever. Okay. Everyone's good. Easy breezy. All right. This is a special case. All right, which one do you want to eliminate, x or y? Y. So what would I multiply the top by? 2. So when I go to add these lines together, the left side, both variables cancel, and the right side is also equal to 0. So is that a true statement? If it is a true statement, 0 does equal 0. We call that a dependent system. All solutions will work. Okay, let's, there's an infinite, let's say infinite solutions. Okay, it's considered a dependent system, infinite solutions. And then on Math Excel, they're going to say x, comma, and then you need to fill in the y. So any point that fills in this x and so the y value, just take one of the equations, it doesn't matter, and solve for y. Get the y by itself. So this is basically saying you can put anything you want into for x, and then the y value would be just plug in the x that you picked. Right? So that's how they're going to ask it in Math Excel. So if it's a special case, these lines are basically the same line, they're multiples. So it ends up being a line on top of itself, which means all the points are intersecting. All right? So it's dependent. If I were to change this just slightly, if I go back here and let's change this to a 10, this would be a 24. Is that a true statement? It's not true, it's no solution. Remember, parallel lines, they're never actually going to hit. That's called an inconsistent system. You need to know those words, all right? So if it's a true statement, we say it is dependent. If it ends up being not true, you say it's inconsistent. All right, we're going to do these. They're not linear, but we are going to solve it as if it were linear. So notice I have an x on the bottom and a y on the bottom. So we're going to go to the side, and you pick whatever letters you want to use. I'm going to use A and B. I'm going to say A equals 1 over x, and I'm going to make B equal 1 over y. So we're going to use those and rewrite this system as two linear lines, or two lines. It's going to be a linear system. So if I rewrite this, the first equation is going to be 2a plus 5b equals negative 5. The second one would be 3a minus 2b equals negative 17. And then you're just to a simple elimination question. You're substituting by 1 over x, right? Because you can write that as 2 times 1 over x, and this is 5 times 1 over y. Okay.
Is it 1 over x and 1 over y like every...
All right, so we're going to solve this. What equation are we going to get rid of? Or which variable, I'm sorry? The b's. So we want to make these 10 and negative 10. So what are we going to multiply the top by? 2 and the bottom by 5, right? Because that would make a negative 10 and a positive 10. So our new equation is 4a plus 10b equals negative 10. 15a minus 10b equals negative 85. So I get a is negative 5. Everyone with me? Then you're going to plug the a in to find our b. So 2 times negative 5 plus 5b equals negative 5. And I get b equals 1. So it's the same idea. You're just going to do elimination to solve those. We still don't know what x and y are, yes? So we're going to go back up, and we're going to say a equals 1 over x. So if I just write the reciprocal of both sides, I get x equals negative 1/5. And b, which was 1, equals 1 over y. Again, I'm going to write the reciprocal of both sides, and y equals 1. So you solve something that's nonlinear with a linear system. Okay? These require you to write a little bit. I know it's a lot of paper. For killing trees, solving math. All right, so that's 2 by 2. Are we okay with 2 by 2s? Really, this is the only thing new that you haven't learned in Algebra 1. You're okay. All right, we're going to do 3 by 3s. You think we can do one example? Let's do this one then. Okay, and they look complicated, but really it's the same thing. It's more of the same, there's more of it. Okay, so again, your choice, which variable do we want to eliminate? X, Y, or Z? Z. All right, so I'm going to get rid of Z. Pick 2 of them. I'm just going to pick these 2 equations. If I'm getting rid of the Z's, I have a 2 and a negative 1 right now. So if I multiply the bottom equation by 2, would I be able to eliminate my z? Okay, so top equation's not changing. Bottom equation is going to become 2x plus 6y minus 2z equals negative 4. So I'm going to rewrite, add them together, and I get that equation. Okay? Just multiply. Okay, now we have to pick 2 more equations, and we still need to get rid of the z. So we pick the top and the middle one. Let's do the middle and let's do the top and the bottom. Because it's going to be easy. What do you have to just multiply by -1? One of those guys? So let's multiply the bottom by -1. So the top is still 2x plus 3y plus 2z. And it does not matter. I could have done the bottom and the middle guy. Negative x plus y minus 2z equals -8. You get x plus 4y equals -1. Now, we're going to put these guys together and do a system. So you're just going to do elimination and then elimination and then elimination again. So in your 3 by 3, you have to pick one variable, and you're going to have to eliminate it twice. All right, what do we want to get rid of, x or y? X. So we're going to multiply this bottom by -4. So my first one doesn't change. My second one becomes -4x minus 16y plus 4 equals 4. I get y equals -1. Then you got to take that and put it up into the original. It doesn't matter which one of the 2 by 2 you put it into. And you solve and you get x equals 3. And then how do you get z? You go back up to one of the originals. 2 times x plus 3 times y plus 2z equals 7. Let me make sure I wrote that right. 2, 3, 2, 7. Yep. So this is 6 minus 3 is 3 plus 2z equals 7. And you solve and you get z equals 2. And you write that as a triple, x, y, and z. Okay? So it's just elimination and elimination and then elimination again. So you have to do elimination 3 times.
Oh, we always write as x, y, z.
Yes, always put x, y, z. Okay? And if it's different letters, always put them alphabetical. All right, in the point. Does that make sense? Can we do this? All right. I know it's 2 days before break, guys. We can do it, though. Tomorrow, work day. It's like we're not even here tomorrow. We're here. Okay, can I click? All right, so pictures of what we're doing here. So each x, y, z equation is a plane. So if you have 3 planes intersecting at a point, you have a solution. Okay, x, y, z. If they intersect all 3 planes at a line, this is a dependent system. Okay, there's infinite number of solutions. If they don't connect, you see these are parallel planes, that would be inconsistent. What about this guy? Do all 3 planes connect in this one here? No, so it is inconsistent. All 3 planes have to touch together. here all three planes are actually the same plane. So that's infinite, dependent. Okay? Same thing, if it connects to a line, it's dependent. Parallel again, inconsistent. And do you see how they don't, I mean, two connect at a time, but not all three of them connect? So that's inconsistent again. No solution. Okay? So, let's look at an example and see when that happens. You ready? Pick a variable to eliminate. I'm going to pick y. Okay, so I'm going to start with these two. What would I multiply the bottom by in order to get something that I can eliminate? Everybody? I'm going to get rid of y. -2. All right. So I have 2x plus 2y plus 2z equals 12. My top equation did not change. I'm multiplying by a -2, so that's a positive 6x minus 2y, positive 22z equals 12. I ran into it. All right, so I get 8x plus 24z equals 24. And then I'm going to pick the bottom and middle guy. I'm going to multiply the bottom by -1. And you're just going to use an elimination. Okay. And then put them together. Somehow I lost my 24 up here. Okay. And then you pick which one you want to get rid of. X or Y. X. Y is pretty big there in those numbers. So we're going to multiply the top by 5 and the bottom by 8. Okay. On the left, my variables cancel, so I have 0 equals 136. Is that true? No, it does not equal, so this is an inconsistent solution. There is no solution. Okay, there is no solution. Does that make sense? And then you're done. At that point, you say, can't do it. And it doesn't matter whether you pick the x, the y, or the z to eliminate the start, it's going to end up in this situation. Right? Don't be closing your notebook yet.
Oh no, I'm just letting it. I have to put everything. I'm running out of material.
Let's see. How many word problems do you want to do?
2.
1, 9, 0.
Wait.
Do we need to do another one of those, or are you okay? This one ends up to be all reals. Are we okay? Okay.
Yeah.
Let's do this one. Easy. Tyler finds that he has 308 coins, all dimes, quarters, and half dollars, that total 54 bucks. If there are 2.5 times as many dimes as quarters, how many of each type of coin does he have? So we're going to write 3 equations here. One with just the total number of coins. So we've got dimes plus the number of quarters plus the number of half dollars equals how many coins? 308. So that's just how many coins we have. The next equation, we're going to talk about money. How much is a dime worth? in dollars?
Cents.
Cents. So we're going to put 0.10D plus 0.25Q plus
1.1.
H equals $54. There are 2.5 times as many dimes as quarters. So the number of dimes equals 2.5 the number of quarters. Right? Let's rewrite this last guy so that he's lined up. So I'm going to take this guy and move him over. So we're going to have a dime minus 2.5 quarters equals 0. And that's how we write the system. And that's as far as we're going to go. Because I think you guys could solve it. All right. They've already eliminated the h in the third equation. So you'd have to rewrite this, eliminate the h, and then you could do the system, the 2 by 2 system. So if you're given a system that's already missing a letter, that's the one you want to eliminate from the other two. Okay? All right. I think we're done.
Yeah.
Yeah.
Really?
Yeah.